Hello, discrete math fans. Let's define a relation R on the natural numbers by saying that x is related to y provided y is equal to x plus 1. This relation is not transitive. Should be straightforward to check this. You should be looking for a counterexample. Since it's not transitive, it's reasonable to ask, what is the transitive closure of this relation? And then we'll see, can this closure be described in a simpler way? Now, this relation is infinite. There are infinitely many, if you will, arrows in the picture. So when we described an algorithm before, it doesn't really work because it may never terminate. And in this case, it won't terminate because there are infinitely many arrows that we're going to need to add. Now, we can argue that in the transitive closure, 1 has to be related to any number that's larger than 1. Okay, why is that? Well, 1 is related to 2, and 2 is related to 3, so we must have 1 and 3 in the transitive closure. And then we know that 3 and 4 is also in there, so 1, 4 is in the transitive closure. And go one more. We know that 4, 5 is in the transitive closure, so we have to add 1, 5. So we could give a proof by induction that 1n has to be in the transitive closure for any n bigger than 1. And then in a similar way, we could argue by induction that 2n has to be in the transitive closure for any n bigger than 2. And then we could argue again by even more induction that for any m and n in the natural numbers with m less than n, mn has to be in the transitive closure. So I'm not going to write out these induction proofs, but once we have this idea, this gives us a simpler way to describe the transitive closure. So I've left off all the induction arguments. You might give it a try to write out an induction proof of all of these facts. And you see we've gotten to the point where we have a simpler description of what's in the transitive closure rather than drawing an arrow diagram or some other description. We can just say that m is related to n if and only if m is less than n. Okay, that's all for now.